Hey, welcome back to Rocket Math. And what we want to do now is talk about disjoint events. Again, we're still looking into probability, but now we want to look at another form of mathematics when we're dealing with these probabilities, which is addition. Before we looked at independent and dependent, and we actually said that we have a probability of A and a probability of B, which means that we are going to multiply to find the actual jointed probability. Here we're looking at disjointed events, and we need to understand that the probability of either of the two events are occurring, and that's the sum of the two individual probabilities. Okay, we also need to understand that the probability of one event following another in independent trials is the product of two probabilities, but here we just want to focus on the actual disjoint part of the actual if one happened, will it affect the other, and then the addition part. Okay, so let's just take a look at what we're talking about, and maybe look at a few choices, actually two choices, and see can we determine which is what. So on a game show, the letters in the word Hollywood are printed on cards actually, and shuffled. So we have a contestant that will win a trip to Hollywood if the first card she chooses is printed with an O or an L. So without even worried about what the actual probabilities are, how many letters or whatever, let's just understand that choosing an O or choosing an L on the first card is a set of disjointed events. Disjoint events are events that cannot all occur in the same trial of the experiment. So let's take an example. We want to look at some examples of, or not so examples of, disjoint events, and determine whether each set of event is disjoint, and we want to explain it. So here we have a basket containing some fruit, and we want to choose a red apple or a green apple from the basket. The basket contains red apples, green apples, bananas, and oranges. So what we want to do is determine, just from what we know, if the actual event is disjointed or not. So let me change the size. Okay, so we want to choose a red apple or a green apple. Has to be disjointed, okay, because we're looking at literally choosing two different things. Okay, so we can say that the event events are disjointed. Okay, so we can say our rationale is because you cannot choose a piece of fruit that is both green, an apple especially, and red. So because they are different, these particular events are disjointed. Well, what about the second one? And let me go ahead and explain why here. You cannot choose a piece of fruit that is both a green apple and a red apple. Okay, now let's take a look at the second one, and we should get some clarity here since we understand exactly what we're trying to do. What about if we want to roll a 6 or roll an even number on a number cube? Think about that. We want to determine what's the probability of rolling a 6 or rolling an even number on a number cube, and we want to determine if these events are disjointed. Well, let's go to the side and list the even numbers on a cube. 2, 4, 6. So if that's the case, then the events are not disjointed. And the reason why they're not disjointed is because 6 is an even number. Okay, so you can actually roll a 6 and an even number, and that'll be actually the same thing. So again, the second example is not an example of a disjointed event. Now, what I really, the important part here is what I want to show you is how we come up with the actual math part. So we're looking at the probability of two disjointed events. So here we have the probability of A or B, and that's going to equal to the probability of A plus the probability of B. Okay, so you just want to make sure that you are careful and understand what we're talking about here. So here we're talking about the probability of either event, and here we're talking about the probability of one event, and here we're talking about the probability of the other event. Okay, so just remember when being honest, just because the word R is in there doesn't, I was going to say look for key wording and look for R, but just because the word R is in there does not make it a disjointed event. So we have to make sure that it is a disjointed event, and if we do, then we take the probability of one event and add it to the probability of the other event. Now, as we remember that we're talking about dealing with fractions, or we're talking about dealing with decimals, you have to be careful here, because if we're looking at two different fractions, you're going to have to find a common denominator when you get ready to add, or literally just simplify it into a decimal. Again, identifying disjointed events.